All right. Converting from order base to base 10. Before doing that, let's first look at this number. If you have a number like 523.211, this is base 10. Now, if I ask what is the numeric value of 5 in this number? What the numeric value of 5 in this number? The numeric value of 5 in this number is 500. Is 500. And then what's the numeric value of 2 in this number? The numeric value of 2 in this number is 20. The numeric value of 3 in this number is what? 3. So if you add 500 plus 20 plus 3 to give you 523. And then numeric value of 2 there is 2 over 10 or 2/10. And then 1 there is what? 1 over 100. And this last one there is 1 over 1000. So if you express all this in standard form, this will be the same as 5 times 10 raised to the power of 2. Of course, 10 raised to the power of 2 is 100 times 5 will give you that. So this one, it can be written as 2 times what? 10 raised to the power of 1. And this one can be written as what? 3 times 10 raised to the power of what? 0. Anything raised to the power of 0 is 1. 2 raised to the power of 0 is 1. 10 raised to the power of 0 is 1. So, and this other one, if you have to express it in standard form, this one will be what? 2 times 10 raised to the power minus 1. This one will be 1 times 10 raised to the power minus 2. And this last one will be 1 times 10 raised to the power minus 3. And for people who may not understand why the minus, according to law of indices, if you have 1 over x raised to the power of n, it's the same thing as when you take x to the numerator, it becomes raised to the power negative n. So that's what we just did here. So that means if you find all these values and add them together, it will give you this number. So this is understanding value of number that are in base 10. So assuming a number that is not in base 10, the number that is in base 5, say like 412.211 base 5. So how are you to analyze the value of this number? It's still the same procedure as you did for that of base 10. So this of 4 is in its place value is 100. Then its numeric value is what? Will be 4 times its base. Remember, this one was 5 times its base raised to the power of its place value. So this one will be 4 times its base. What is its base? 5. Raised to the power of what? 3. And here will be what? 1 times 5 raised to the power of 2. And here will be 2 times 5. Did I say 3? Sorry, here will be 2. It's a mistake. Sorry for that mistake. This will be 5 raised to the power of 2. I'm following the same procedure. It's 100. So it will be raised to the power of 2 times 5 raised to the power of 1 and then times 5 raised to the power of 0. So here will be the same thing. This will be 2 over 2/5. That's the 2 over 5. Just the same way we did this one. And that 2 over 5 is the same thing as what? 2 times 5 raised to the power minus 1. So you follow the procedure accordingly. This will be 2 over 5 raised to the power 2, which is the same thing as 2 times 5 raised to the power of what? Minus 2. And the last one, of course, is, oh, sorry, here is 1, not 2, 1. 1 over 5. The last one is 1 over 5 raised to the power of 3. It's the same thing as 1. Here is 1. 1 times what? 5 raised to the power of what? Minus 3. So if you calculate all these things and add them together, it will give you the equivalent of this number that is in base 5. It will give you the number in its base 10. Okay, let's cut the story short and do something. Take example. So we have a number, say 211.22. This is base 3, and want to convert it to base 10. So simply, this is how you do it. You take the first number 2 times the base, plus the second number 1 times the base, plus the third number 1 times the base. Forget about the decimal point, but after the decimal point, it will be the first place value there times the base. But this time around, it will be raised to the power of minus 1 plus 2 times the base, raised to the power of minus 2. So before the decimal point from here is 0, 1, 2. That's the power. So the power here is 0, 1, 2. Have you seen that? You want to convert it to base 10. So 3 times 3 will be 9. 9 times 2 is 18. Plus 1 times 3 is 3. Plus 3 raised to the power 0 is 1. So 1 times 1 is 1. Plus. This will be 2 times what? 1 over 3. That's 2 over 3. This one is 2 over 3 plus the next one, 2 over 3 raised to the power of 2. So if you add all these, 18 plus 3 is 21, plus that 24. 24. 24 plus 2 over 3, if you convert that to decimal, what will it give you? 0 0.667 plus 2 over 9. You know, 3 raised to the power of 2 is 9. So 2 over 9 is 0.222. So if you add all these together, you have 24.889 base 10. So therefore, 211.22 base 3 is equivalent to what? 24.889 base 10. Have you seen how simple that is? So let's take another example to further make you understand it better. Let's take another example. This time around, we take a base 2 number. So this is a simple way to do this. This one it has no decimal. So this one is say 1 times 2 plus 0 times 2 plus this other 0 times 2. Then you identify the power 0, 1, 2. 0, 1, 2. So this will be 2 raised to the power 2 is 4 times 1 is 4 plus 0 times 2, 0. 0 times 2 is 0. So the final answer is 4. So therefore, 100 base 2 is equivalent to what? 4 base 10. 4 base 10. So let's take another example with a number, binary number that has a decimal. 110.0101. So let's do that. So you allocate your powers 0, 1, 2. Here will be -1, -2, -3. And that's after the decimal point. So this will be 1 times 2. The first one is raised to the power of what? 2. Plus 1 times 2 raised to the power of what? 1. Plus 0 times 2 raised to the power of what? 0. Plus this one, 1 times 2 raised to the power of what? -1. Plus 0 times 2 raised to the power of what? -2. Plus the last one, 1 times 2 raised to the power of what? -3. So here will be 4 plus 1 times 2 is 2 plus here will be 0. 2 raised to the power of 0 is 1. 1 times 0 is 0. And here will be plus 1 over 2 plus 0 times anything is 0. Here will be 0 plus 1 over 2 raised to the power of 3. This is equals to 4 plus 2, 6. 0 the same, 0 the same, plus what? 1 over 2 plus 1 over 2 raised to the power of 3. 6 plus 1 over 2 is 0.5. 1 over 2 raised to the power of 3, which is the same thing as 1 over 8. And 1 over 8 is 0.125. 0.125. So when you add all that, 0.125 Rather that we have 6.625. 6.625 base 10. So I've successfully converted this binary number to a denary number. So let me quickly give you something to try to test your understanding. So convert 212.11 base 3 to base 10. Then also number 2, convert 23.2 base 4 to base 10. Then number 3, convert 81 base 9, 1 base 9 to base 10. So you pause the video and try it out. Then I'll display the answers of that to you. All right, let's solve it. So for the first one, 113 to base 10, you allocate the powers 0, 1, 2. Here is -1, -2, and okay, 3 is the base. So this will be 2 times 2, 2 times 3. The base is 3, 2 times 3 raised to the power of 2, plus 1 times 3 raised to the power of 1, plus here will be 1 times 3 raised to the power of -1, plus 1 times 3 raised to the power of -2. So 3 raised to the power of 2 is 9. 9 times 2 is 18. 1 times 3 is 3. 1 times that, that's plus 1 over 3 plus 1 over 9. That's 1 over 3 raised to power 3. And 3 raised to power 3 is 9. So 18 plus that would be 21 plus 1 over 3. 1 over 3 is 0 0.3333. 0 0.33. And 1 over 9. 1 over 9 is 0 0.1111. So final answer, if you add that, plus you have 21.44 base 10. So that's for the first one. Then for the second one, number 2, you have 23.2 base 4. So you're looking at the power 0, 1, minus 1. So this will be 2 times 4 raised to the power 1 plus 3 times 4 raised to the power 0 plus here will be 2 times 4 raised to the power minus 1. So 2, 4, 8. And 4 raised to the power 0 is 1. 3 times 1, 3 plus 2 over 4. 1, yeah, 2, that's 0. So 8 plus 3 is 11 plus 0 0.5, which will give you 11.5 base 10. So we've converted this base 4 number to base 10. So if you got that, very good. And then the last one, 81, you allocate 0, 1. So this will be 8 times the base, which is 9 raised to the power 1 plus 1 times 9 raised to the power 0. And then 8 times 9, 8 times 9 is 72 plus 1 give you what? 73 base 10. So if you got all that right, that means you're good to go.